Hi there, welcome to brilliantmaths.com, where every student has an opportunity to excel in maths. Today we have an interesting lesson on trigonometry. So join me and let's go to class. Today we'll be looking at trigonometric ratios, the sine, cosine, and tangent ratios for acute angles. So we'll actually be looking at right-angled triangles. So for example, we have a right-angled triangle ABC, and we have an acute angle at X. First, we need to learn how to name the sides of the triangle in relation to the angle X. So for angle X, it's a right angle triangle. The slanted side is called the hypotenuse. The hypotenuse is directly opposite the right angle, as you can see. So angle X, the side opposite angle X, is the opposite side to angle X. And the side at the bottom is the adjacent side. So to find the sine of angle X, sine X is equal to the opposite side over the hypotenuse. So sine X is equal to O over H. That's opposite over hypotenuse. So as you can see, the opposite is the line AC. So we have AC over the hypotenuse is AB. So sine X is equal to AC over AB, which is the opposite over the hypotenuse. What if it's a cosine ratio we want to find for the same angle X? So the cosine ratio of X, for short, we can write cos X. Cos X is equal to the adjacent over the hypotenuse. So adjacent, A, over hypotenuse, H for short. And then using the lines of the right angle triangle, it will be BC over the hypotenuse, which is AB. And finally, the tangent of angle X, the ratio for tangent is opposite over adjacent. So tan X is equal to the opposite, O, over the adjacent, which is A. And then that gives us the opposite is AC over the adjacent is BC. So that's how to find the trig ratios for a right-angled triangle. We have our angle at the bottom here. So what if the angle is on top? Does it differ? The hypotenuse remains the side opposite the right angle. So that's the slanted side, and it's very easy to identify. Always label out the sides of your triangle so you'll be correct. So that's our H. For angle Y, where will be the opposite now? The opposite to angle Y will be the line RQ or QR. So that will be O. And then the adjacent for angle Y will be the line PQ. So we'll call that A. So in the same way, the sine of Y will be equal to opposite over hypotenuse, O over H, and that will give us the opposite is QR over the hypotenuse is PR. Then for the cosine of angle Y cos y is equal to adjacent over hypotenuse, adjacent over hypotenuse, and the adjacent line is the PQ, and the hypotenuse is the PR. And then finally, the tangent of y, the tangent of angle y, tan y, is equal to the opposite over the adjacent. That is O over A. And then O, we know, is RQ or QR over A, and A is our PQ. So we have learned how to find the sine, the cosine, and the tangent ratios of a given acute angle. Let's look at another example. In this example, we want to learn how to find the length of unknown sides in a right-angled triangle, given any angle. So example 1, it says find the length of AB. AB is a line here. We have our right angle at point A, and the line opposite angle A is 80 meters. That line is the hypotenuse of the right-angled triangle. So we have triangle ABC. So the sine of angle C is 22 degrees. The sine of angle C, like we learned earlier, is equal to the opposite line over the hypotenuse. So where is the opposite line here? Angle C, opposite to angle C is AB, and that's the length we are finding. So that is opposite. So we have AB over hypotenuse, and the hypotenuse is 80 meters. So to find the length of AB, we simply cross multiply. So AB is equal to 80 meters times sine 22 degrees. So take out your calculators and let's find the length of AB. So we have 80 times sine 22 degrees. And what do we have? The answer is 29.97 meters. So AB is equal to 29.97 meters. So that's approximately 30 meters. So line AB is approximately 30 meters long. In example 2, we have a right angle triangle, triangle ABC, and the right angle is at B. The hypotenuse is 24 centimeters long, and we have an angle at C which measures 75 degrees, and we're supposed to find line BC, which has been labeled X. So if we have the hypotenuse, and we're to find the adjacent line, then we should be using the cosine ratio. So cos 75 degrees, we know that cos is adjacent over hypotenuse. So that is our X over 24 centimeters. So again, to find X, we simply cross multiply. So X is equal to 24 centimeters times cos 75 degrees. So we take out our calculator and we input 24 times cos 75 degrees. And that gives us 6.21. That means line X is equal to 6.21 centimeters. So next, we need to look at how to use the tangent ratio to find the length of an unknown side. In this example, we want to find line X, the side marked X. And we've been given the angle 31 degrees, and we have the line directly opposite the angle. We are finding the adjacent line. So we don't have anything to do with the hypotenuse. So what does that tell us? We should be using the tangent ratio. So tan 31 degrees, tangent is opposite over adjacent, will be 20 centimeters over x. So how do we find the length of x? We'll cross multiply. So that means that x tan 31, x times tan 31 degrees is equal to 20 centimeters. So to find x, we divide 20 centimeters by tan 31 degrees. So x is equal to 20 centimeters over tan 31 degrees, which is equal to, so we take out our calculators. So we have 20 divided by tan 31 degrees. And what does that give us? That gives us 33.29 centimeters. So the length of line X is equal to 33.29. So we can call it 33.3 centimeters. So that's the length of X. X is equal to 33.3 centimeters. In this next example, we want to learn how to calculate unknown angles. We already know how to find the sine, the cosine, and the tangent of any given angle. Example 1, it says find the measure of the angle marked x. We have triangle ABC, and angle x is at the point A. And we are given line BC, which measures 7 centimeters. And we have line AC, which is the slanted side, the hypotenuse, which measures 12 centimeters. So you would have to determine what ratio to use. Are you using sine? Are you going to use cosine or tangent? How do you know? Look at example 2. It says find the value of y. We have angle y there at C. A right angle triangle is ABC. The right angle is at B. And we have the length 3 centimeters, which is opposite the angle C. And we have the adjacent. So you also have to determine which ratio to use. So here is the trick. Look at the sides you've been given and see how they are related to the angle you are supposed to find. So we have angle x. We have the hypotenuse, and we have the opposite. So definitely we're supposed to use the sine ratio. So sine x is equal to opposite of a hypotenuse, which is 7 centimeters over 12 centimeters. But this is the sine of x. But we want to find the value of x. So we'll be finding the sine inverse of 7 over 12. So x is equal to sine inverse of 7 over 12. So you take out your calculators. The sine inverse is a second function. So shift sine inverse. Then that gives us 7 over 12 is a fraction. So we input the values 7 over 12. And we have 35.69 degrees. 35.69 degrees. So that means that angle x measures approximately 35.7 degrees. So x is equal to 35.7 degrees to 1 decimal place. So in example 2, what ratio are we supposed to use? We have the angle y is the angle we're finding, and we have the opposite and the adjacent. We don't have anything to do with the hypotenuse, so the sine rule, the sine ratio, the cosine ratio is out. Opposite and adjacent is related to tangent. So we're finding the tan of y. So tan y is equal to the opposite, which is 3 centimeters, over the adjacent, which is 8. So again, we have to find the tan inverse to be able to get the value of y. So y is equal to tan inverse of 3 over 8. So we'll put that into the calculator. It's a second function, so shift tan 3 over 8, and that gives us 20.56 degrees, which is equal to 20.56 degrees. So angle y actually measures 20.6 degrees. So in calculating or finding the unknown angle, you would either be finding the sine inverse, the cosine inverse, or the tan inverse, depending on the relationship between the angle you're finding and the sides that you have been given. It will all be left to you to decide. But take a look at this. Make sure that you are able to determine your hypotenuse, because if you get the hypotenuse wrong for any of them, then your answers will most likely be wrong. The hypotenuse is a very strong factor. Once you can determine the slanted side, the hypotenuse, and determine the adjacent and the opposite to the angles you're finding, then your job is done. So pay attention to finding, being able to label the sides, the relationship between the angle and the sides that have been given. Feel free to pause the video, watch it again and again, just in case you don't understand. In this next example, we want to find the length of x. But as you can see, we have a composite figure. This shape is actually made up of two triangles. We have triangle ABD and triangle BDC. We want to find the length of x. But before you can find x, you need to be able to find either BD or AD. But what will determine which one we'll find depends on the first triangle here, triangle BCD. All right? So first, let's consider triangle BDC or triangle BCD. We'll find BD, and to find BD, we have angle 42 degrees. And BD is opposite angle 42 degrees. So we have the opposite and the adjacent. So we'll be using the tan ratio. So tan 42 degrees is equal to opposite, which is BD, over the adjacent, which is 13 centimeters. So next, BD is equal to, we cross multiply. So we have 13 centimeters times tan 42 degrees, and that gives us 11.7 centimeters. So that means that BD is 11.7. So line BD is 11.7. We have the angle at D, which is 38 degrees. So what are we supposed to use? To find x, we need to consider the triangle ABD. So from triangle ABD, the sine of 38 degrees is equal to the opposite over the hypotenuse. You must note that the hypotenuse of triangle ABD is 11.7. That's the line opposite the right angle. So sine 38 degrees is equal to opposite over hypotenuse, and that is x over 11.7. 7. So to find x, that's a value of AB, how long that line is, we multiply 11.7 centimeters by sine 38 degrees. And we find that x is equal to 7.2 centimeters. Try that out. I've worked it all out. So you take the steps and work it out, and you'll find out that you'll get the same answer. Don't forget to practice it on your own so you can actually own the learning. In this next example, we want to look at some important facts. So for a circle is a complete revolution, and we have an angle of 360 at the point. So each quadrant is equal to 90 degrees. So what I want you to understand is in the first quadrant, which is from 0 to 90, all three trig ratios are positive. So the sine of any angle between 0 and 90 is positive. The cosine is positive. The tangent is also positive. You can check that with your calculator. But when your angle is greater than 90 degrees, but less than 180, so you are in the second quadrant. In the second quadrant, only sine is positive. Take your calculator and check it out. Find the sine of, let's say, angle 100 degrees. So in your calculator, you're finding sine of 100, and that is 0.98. Then find the cosine of 100 degrees. What do you notice? Cos 100 is equal to minus 0.17. So in the second quadrant, cosine is negative. Let's also find the tangent. Tan of 100, and it's minus 5.67. So in the second quadrant, cosine and tangent are negative, while sine is positive. In the third quadrant, only tan is positive. Sine and cosine are negative. And in the fourth quadrant, sine and tan are negative, while cosine is positive. It's just interesting for you to take note of that. Then next, we look at the trig ratios for special angles. Let's say angle 30 degrees and angle 60 degrees. For angle 45, you'll find that in Brilliant Maths Module 6. So today we're just going to look at how to find values for angle 30 and 60 degrees. We have an equilateral triangle ABC. So if the triangle is equilateral, that means that all the sides are equal and all the angles are equal to 60 degrees. So angle A is 60 degrees, angle B is 60, and C is also 60. So we construct a perpendicular bisector. That's a line that divides the angle C into 2 and also divides the line AB into 2. So the point of contact is D. So CD is perpendicular to AB. So we have 60 degrees. So using Pythagoras, we can say that CD squared is equal to AC squared minus AD squared. AD is 1 because it's been bisected. 2 divided by 2 is 1. Half of 2 is 1. And then AC is 2. And that's our hypotenuse for the right-angled triangle ACD. So CD is equal to AC squared minus AD squared. So to find CD, we'll find the square root of AC squared minus AD squared. AC is 2, so 2 squared minus 1 squared will give us 3. So that means that CD is equal to root 3. So the length of CD is equal to root 3. We have just found that. So we're going to use those dimensions to find values for our angle 60 degrees and angle 30. So for sine 60 degrees, we know that sine is opposite over hypotenuse. So sine 60 is equal to root 3 over 2. Cos 60 is adjacent over hypotenuse. So cos 60 is actually half, or 0.5. Tan 60. Tan 60 is opposite over adjacent, which is equal to root 3 over 1, which is equal to root 3. So tan 60 is root 3. So now let's find the sine, cosine, and tangent of 30 degrees. Sine 30 degrees is equal to opposite over hypotenuse. So sine 30 is half. Cos 30 degrees is adjacent over hypotenuse, which is root 3 over 2. And then tan 30 degrees is equal to opposite over adjacent, which is 1 over root 3. And if you have 1 over root 3, you're supposed to rationalize the denominator, and that gives us root 3 over 3. So those are special angles. So you can actually calculate sine 60 degrees, cos 60, tan 60, and the rest of them without using a calculator because we know the values. Take your time to go over this lesson, and for more of this, get a copy of Brilliant Maths Module 6. I hope you enjoyed today's lesson. The lesson was actually from Brilliant Maths Module 6. Get a copy of Brilliant Maths Module 6 and do some more work. Practice, practice, practice. Subscribe to brilliantmaths.com. There are lots and lots of exercises there for you. And follow us on all our social media handles. My name is Ngozi Orevogene. And always remember that maths is fun and you can excel in it.